Hey there, this is going to be a quick video as a review of quiz number 6. This quiz had 5 questions and most of them were true-false, but not all of them. And the topic of this was G sub C design mostly, transfer functions and compensator block design, and just features of that. So question number 1 was a true-false question, and the question reads, G sub C is a compensator block in parentheses control block, which is designed as a transfer function format control algorithm. Now, if you've watched the lectures for this, you'll see that that is true. That's basically what we're doing. We're designing G sub C in order to stabilize a system or to send the output to a certain set point or a tracked signal. Question number 2 was also true-false, and this one reads, according to the minimal order design technique, which is what we're following, we must start with the most complex case for G sub C design, so right immediately that should sound wrong to you. Doing so, we can avoid trial designs and therefore minimize calculation work needed. So that's opposite of what we're doing. We are starting with the simplest design first and working our way up from there. The first simple design that works is the one that we'll end up using, as long as it satisfies our criteria for our control task. This was true-false, of course, and this answer should have been false. Okay, question number 3. For a system, and you're given a plant here, G sub P, with a 10 in the numerator and an S minus 4 in the denominator. You are supposed to choose the characteristic root and the system stability. So the characteristic root here for this system should be in the denominator. What we're referring to is actually the pole, and the thing that relates to the system stability is going to be the pole in this case. So for G sub P, you'll look at this denominator S minus 4. If you set this equal to 0, you should find that the root of this is 4, positive 4. That's going to be over here in the right-hand plane. And so the correct answer out of these 4 choices is positive 4 and unstable. Okay? All right, for question number 4, you are told to choose 3 answers for this question, and each are worth 1 point. This was a 3-point question. So again, we have the same plant, G sub P, with a 10 in the numerator and an S minus 4 in the denominator. And we are told to choose the first 3 G sub C trial designs. For this, for stabilization, we would follow the pattern of KC over 1, which was answer D, KC over S plus A, if that didn't work, which is answer F, and then KC S plus B over S plus A, which is answer A if the earlier 2 did not work. So your correct answers would be D, F, and A for this, and it just follows our normal minimal order G sub C design technique with no free S's included. We're not talking about free S's for this. This is just the stabilization case. Okay? And by the time that you took this quiz, we would not have really delved into free S in depth yet. Okay. Question number 5. For a system represented in differential equation format affected by a disturbance, we designed control algorithms utilizing integrals of either y of t or error e of t to achieve a disturbance rejection, which is really accommodation for our purposes. Which of the following methods are the transfer function control algorithm equivalent of this? So what are we doing now in transfer function format that is the equivalent of adding in the integrals earlier? So you have 4 choices, and the only one that should stick out to you that is really something we've talked about at all is the free S. The choices were integral division, the free S, control matrix B, and linear quadratic estimation LQE. So the bottom 3 of these are actually real things, and the correct answer is, of course, the free S. That's the only one that we have dealt with in this class so far. Okay, so that completes quiz number 6.